Proxy Data by Selena Scola. April 2, 2024. SCO at sas.upenn.edu. How does climate proxy work? Proxy records are and serve as evidence of past states of climate preserved in fossils, sediments, and oral or written records such as daily weather logs. According to NOAA National Centers for Environmental Information, paleoclimatologists are scientists who study past climates and collect measurable data from corals, pollen, ice cores, tree rings, caves, packrat middens, ocean sediments, lake sediments, and historical written data. This tangible collection of data is known as proxy data, utilized to explore past climates on Earth, enhancing our understanding of historical climate conditions. What does proxy data tell us about past climates? Proxy records have revealed natural cycles and variabilities in the Earth's climate system, such as glacial cycles and periods of abrupt change. By understanding these natural patterns, scientists can distinguish between natural variability and anthropogenic influences on the current climate. According to National Geographic Education, analyzing tree rings, a method called dendrochronology, offers paleoclimatologists clues about the historical temperature and rainfall patterns during a tree's lifetime. This knowledge helps scientists hypothesize about historical temperature shifts and drought periods. Analyzing the fossils of marine creature shells, such as diatoms and foraminifera, serves as another proxy. Over time, these shells have settled under sediment layers, encapsulating chemicals from when the shells were formed. By examining these chemicals, researchers can infer the water's chemistry and temperature when these organisms existed. Scientists can drill into ice sheets to retrieve ice cores and analyze trapped deposits, including pollen and gases, to gain insights into the atmospheric and climatic conditions prevailing when those ice layers were formed. This compilation of proxy data enables the construction of a comprehensive picture of Earth's climate across various geological periods. Paleoclimate reconstructions utilize historical oral and written records to provide qualitative insights to complement quantitative proxy data. Oral traditions detail phenomena like droughts and floods, while written accounts record weather events, crop cycles, and species prevalence. These narratives complement proxy data, adding a human dimension to the scientific analysis of climate history while enriching our understanding of past climates. What time period does proxy data cover? Proxy data covers an expansive range of time, spanning hundreds to millions of years. Thus, collecting and comparing various proxy types from numerous locations gives us a more comprehensive understanding of historical climates. How accurate is climate proxy data? Proxy data bias or inaccuracies often arise from issues such as incomplete datasets. An example of such is having ample longitude data while lacking the corresponding latitude data, which can skew results and lead to incorrect reconstructions of Earth's climate past. To ensure the reliability of proxy data and reduce bias during climate reconstructions, it is important to use a wide range of historical climate indicators, account for data inconsistencies, perform thorough cross-reference tests, and assess for impactful events. This approach ensures a more comprehensive understanding of how data inconsistencies affect proxy data, facilitating a more accurate and precise account of Earth's climate past. What are the limitations of the climate proxy data? Is it restricted to certain locations, climates, or time periods? Climate proxy data are invaluable for reconstructing Earth's past climates, especially for periods before direct measurements are available. However, proxies do not exist in isolation from the impacts of evolutionary changes, natural degradation, environmental factors such as nutrient availability, or bias during the reconstruction process. In other words, isolating the climate signal from external influences is challenging. Despite these limitations, climate proxies remain necessary for understanding Earth's climate history. Molluscs. Now that we know a bit about proxy data, let us hone in on some specifics. Today, we will learn about the mollusk and where it fits in relation to the proxy data. What is a mollusk? A mollusk is a member of a large phylum of invertebrate animals known as mollusca, which are further divided into classes such as gastropoda, snails and slugs, bivalvia, clams, oysters, and mussels, cephalopoda, octopuses, squids, and cuttlefish, and more. The mollusks of our focus have soft bodies protected by a hard shell made of calcium carbonate. Mollusks live for years to decades, are somewhat stationary creatures, and their shells record microscale variations in their environment, capturing environmental changes precisely where they live. They are grazers, predators, scavengers, and filter feeders, making them an integral part of Earth's ecosystem. They live in environments such as the deep ocean floor, freshwater rivers, and on land, thus creating welcoming conditions for paleoclimate reconstructions due to their global occupancy over millions of years. The shells of mollusks, such as clams, oysters, and snails, contain shell carbonate, CaCO3, created during shell formation as the mollusk extracts calcium, Ca2+, and carbonate, CO3 ions from the surrounding waters. The shell develops bands as it grows, providing a chronological record of its growth and reflecting variations in environmental conditions such as temperature, food availability, oxygen levels, and salinity. These bands provide a continuous record of environmental changes over their lifespan, allowing for precise dating and seasonal resolution of past climates. Scientists use the oxygen isotope ratios in mollusk shells to reconstruct past environmental conditions, such as ocean temperatures and ice volume. Oxygen isotopes are oxygen atoms that develop during calcium carbonate, CaCO3, formation in the shell. Researchers focus on oxygen-16, 16O, a lighter isotope that evaporates faster than oxygen-18, 18O, which is a heavier isotope that condenses easily, a phenomenon known as isotopic fractionation. To reiterate, paleoclimatology scientists analyze the isotopic composition of the fossilized mollusk shells and use the oxygen isotope ratios in shells to reconstruct past environmental conditions, such as ocean temperatures and ice volume, as cooler conditions are indicative of oxygen-16 and warmer water conditions are indicative of oxygen-18. Thus, researchers can infer the temperature of the seawater in which the mollusks lived, providing valuable insights into historical climate shifts over geological timescales spanning millions of years. What time period does mollusk proxy data cover? Mollusks first appeared on Earth during the Cambrian period, which started around 541 million years ago. This era is notable for the Cambrian explosion, a period of rapid evolutionary diversification where many major groups of organisms, including mollusks, first emerged in the fossil record. Sediment cores and mollusk shells. Sediments from the ocean floor or lakes accumulate layers over millennia, capturing past Earth's climate's chemical and physical properties. Mollusk shells within sediment layers accurately record environmental conditions, including changes and their duration. Fossil records, including those from mollusks, illustrate historical ecosystem response to climate shifts, proving valuable for predicting current and future climate change and plausible impact on biodiversity, ecosystems, and living conditions on Earth. Conclusion. In conclusion, proxy data offers insights into Earth's historical climate variability, enabling scientists to assess rates of past climate change while providing a benchmark to measure present-day climate conditions to identify systems of resilience and vulnerability. Paleoclimate research highlights the importance of mollusk shell analysis, which accurately records current and past ocean conditions, such as temperatures and salinity, further contextualizing the rate of present-day atmospheric and oceanic changes due to global warming. Understanding historical climate variability utilizing proxy data to identify regions of high resilience or vulnerability supports the development and deployment of policy-backed mitigation efforts in preparation for and adapting to the continuous impacts of climate change. In summary, The historical insights provided by proxy data, including those from mollusk shells, enhance our understanding of the Earth's climate system and offer valuable lessons and warnings critical for addressing the challenges posed by current and future climate change. Thank you for listening. Selena Scola. April 2, 2024. sco@sas.appen.edu. Sources and figures listed on the next slide.